All right.
Yeah, TGIF. Got a little money on the Spotify check. Shit been picking up, but I've been paying off debt. Haven't had a minute here to take a breath yet. No sweat, ain't nobody got it like this. A year ago, was picking up a couple side shifts. Funny how the tide shift. At least I know I got a lot of people like to bumping my shit. Yeah, I keep getting better, they keep getting better. Turning 26 letters into 6 figures. God willing, gotta keep the wheel spinning. No ceilings, no chilling. Got a pretty dope feeling. Boy, all my shit fuego. Don't be throwing rotten tomatoes. Since Egos and Legos, I've been like Lego. Baby, let's do it. Talking brass tacks, trying to get down to it. Oh, hey, hit every line with a blitz. Hey, man, it's first right here to 10. Hey, put some Henny. Damn, this shit might make me a rich man. Some people that told me you can't swing, but I guess the payback of things ain't it. We gotta turn over every stone. Shout out to Justin to take us home.
Get things done in a minute. Say I talk big, but I live it. Yeah. Get things done in a minute. Say
I need to go and get my butt pillow. I left it outside. And a drink. Pillow. Here. There's a diet right. No, that diet right has bit the dust. One of these. I'll take one of these. Let's get my restream chat going. I do believe I lost. Oh, there it is. So. So it should be coming off this way. So one of the things I need to do . It's not focusing very well, is it? What is all that junk? There's some kind of junk in there. I gotta wipe it off. So. Probably not smart to use alcohol wipes while the thing is at 190 degrees Celsius. There's literally some kind of black goo in here. I mean, I know it's not from any of my stuff leaking, but so I'm gonna let this thing cool down. I'm gonna let this thing cool down, and while I'm doing that, I'm gonna work on this filament here. So I got this little washer right here that I'm going to be putting in the PTFE tube, but it doesn't go in very well, so I figure I probably need to get wherever my there's a little screwdriver over here somewhere. Actually, I need to see if any of these will fit. So I got these little things. I need to find out what hole circumference this is. So this is roughly about the same size. Roughly about the same size. Yeah, it fits right in there. So we're gonna slowly drill it out. Let's grab this right here, and let's twist it around for a little bit. should take care of that. So let's find that filament again. So we want to make sure that this thing goes in good. We won't be snagging on anything. Alright, that'll do. So this thing is at 80 something degrees still. Probably extremely hot. But there is some kind of film on top of it. Like something sticky got. I don't know what it is. But it's all over my silicone sock. It's like some kind of grease, so I need to go and wash this up. Question is it water soluble? I don't know. What is this? So I don't know what it was in there, but it seems to be a lot cleaner now. But I need to wait for this thing to cool down. So what I'm going to do is, help that along by putting the fan piece on for just a second. So I'm gonna let that cool off for a little bit. Trying to get it back to room temperature. Testing 1, 2, 3. No, I'm not too sure if my voice is coming through at all. Is it hot enough that I can... Yeah, it's hot enough that I can handle it. Hot enough to handle. So what I'm going to do is I'm going to take some alcohol wipes right over here and wipe up the bottom. I don't know what the hell that is. It's all over my extruder. I don't know what the fuck that is, but it was leaking out pretty badly. Looks of it.
You're beautiful and damn it's true. You know I wouldn't wanna lie to you, so trust me when I say, yeah, 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 yeah. I found love and I live for you. Yeah, 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 yeah. I found love and it's all for you.
I knew I was gonna need my X-Acto knife set. Where is it? Inside my dying soul, just stay with me until we're growing old. Got the light and it's shining through. You say you're beautiful and damn it's true. You know I wouldn't wanna lie to you, so trust me when I say, yeah, yeah, yeah. I found love and I live for you. Yeah, So 91% PTFE alcohol. So I really can't see in that hole. I think I need a stronger light. Hey Winnie, Winters. I don't know what that is. There's something in that, like some kind of grease. I don't know what the hell it is. I've never seen a Bowden tube put that shit in there. Or at least any of the videos. So I need a strong light, but I can't seem to find one. There's never a small light. Ouch. Also, it's not going to be making it easy for me because I have no lights. I'll be right back. Did I turn the light off? Seems I did. And I'm about to step outside now. So I've got a big flashlight. It's not very bright though. So, let's check in the hole. There's still a bunch of gunk down there. I need to push it harder. Maybe if I take off a little bit. Well, no, I'm actually upgrading the Bowden tube on it, but when I pulled the Bowden tube off, it actually was extremely hard to pull off. There's all this black stuff. I mean, some of it is probably filament from the black filament, but a lot of it is not. So I'm putting a better Bowden tube in here, but when I tried pulling that sucker out, yeah, it was impossible. there was some kind of weird gunk in it. And I had no idea what the hell it was. It's like it was holding the bulging tube in. Sure. This is the factory. So what are you up to? Leveling a monk? Oh, you're still playing. Wow. Right now, I'll put mine on hold. It seems my guild just decided to go kaput. Damn it, what is that? There's still something down there. Let's clean off this. Ah, fuck, I do need to go back outside because I left something inside the mailbox. And it's freaking raining. Ah, that stuff is still in the back. What is that? Well, I'll be right back. I need to run outside and take my headsets off because I don't want to get getting wet. Be right back. oddly enough, they ring that up. So let me go see if I turned that light off in the van. And also, nobody's going nowhere tomorrow. I better grab. I don't remember if I took my medication tonight. Did I take my medications? I don't know. Just in case, I will take a shot of insulin, fast acting. Whatever happened to my insulin? Here it is. Yay for insulin! Yay! Ouch. What's SPC or SCP? Ouch. Ouch. Ow! That burns. Oh, nothing like pain. So, I'm going to break open my new Winson. Brand new Winson copper nozzles. Huh, interesting. So a whole ton of brand new. Of course, these are bigger. What the hell size is this? These nozzle heads are huge compared to the itty bitty little one. So here's the new nozzle, and turn it this way. New nozzle, old nozzle, and the new nozzle. The head's a little bit bigger, so I'm gonna have to go outside and find. Oh, well, I don't know what is that? That looks like an 8. Because the small nozzle is a 6, but as you can tell, I was having a little bit extruding problems where there's black gunk buildup, plastic buildup on the tip of the nozzle. So it looks like it was leaking up somehow. So let's put that up there. So I'll be right back. People, also people videos doing reading the files, YouTube. So just a bunch of people, doing Men in Black things, huh? Sounds cool. Let the aliens come to Earth. They'd probably do a better job than half the politicians out there. Right?
Open eye, feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move. You can make me move. Can make me. So alive, make it last forever. Stop in time, yeah, I'm surrendering. Hold tight, chemicals collide. Hold tight, hold tight. Dripping lights paint the skies, all because of you. Dripping lights paint the skies, only you can make me move. You can make me move. Can make me move.
Well, I ungracefully lost the nozzle somehow. Yep, ungracefully lost the nozzle. It's a good thing I've got a whole bunch more, huh? I wasn't about to kneel down on the ground, especially since I saw that scorpion. Like, nope. Scorpion, nope. Nope. No scorpions. Besides, it probably got dirty when it hit the ground in the tool shed. No scorpions. Supernatural things too, huh? See, I got a whole packet of force. Whole packet. So I'm going to bring over this video. That's not it. That's not it either. Is it this one?
Welcome to today's.
Nope. Not that one either. Ah, what the hell? Okay, that's part of it.
All right. So you only get it. through Luke's.
So I'm going to put this down a little bit.
The hot end fix helps solve the issue found in section 3.1 titled Nozzle Clogs or Filament Drag Issues. It's where the PTFE tube pulls back from the inside of the nozzle, shown here. It causes a space or void between the nozzle and the PTFE tube. When this happens, it allows the filament to melt during heat creep and when the machine is running at operating temperatures. And when it melts, the filament starts to fill into that void. The melted filament that fills the void can harden, and that restricts the path to the nozzle, causing drag. Some of the symptoms of this are stepper skipping, variation in flow, and retractability. This video will go through the hot end fix and show you how to make your machine run so much smoother. Now that we know what causes the issue and some of the side effects, let's answer the big question. Why this fix? Number one, because it takes the Bowden fittings duties for holding the back of the PTFE tube tight against the nozzle away from the Bowden fittings grabber teeth, shown here. It does this by taking the Bowden fittings body and securing it against a space.
So I don't even know what happened to that. There it is.
This takes away from the void that often happens with the factory arrangement. At this point, you'll want to go to Luke's Thingiverse page. It's linked below. Print a few of those washers and the cut gauge for your printer. If you can't print due to one of the issues above, go to section 3.1 and follow those instructions first. Then come back to this video. Now that you have the washers and the cut gauge for your printer, let's go through the instructions. Step 1. Take one of the washers that you just printed and make sure you're able to pass a piece of the filament loosely through the center hole, like this. Step 3. Make sure that the PTFE tube fits through the cutting guide or gauge.
I don't want to go too tight.
At this point, you want to remove the fan shroud. In my case, I have a bullseye blower, so I'm going to remove.
So what did he say? He said something about cutting something.
So at this step 3, make sure that the PTFE tube fits through the cutting guide or gauge.
Yes, the cutting gauge, which is this little thing right over here, which I cannot find suddenly. There it is. Little tiny cutting thing. Cutty. Put that up there. So, cutty. Little cutty thing. So, if you're noticing my middle finger sticking out like that, I'm not telling you to go screw off, folks. It's just that my finger does not move anymore. Doesn't move. See? See? Finger doesn't bend anymore. Does not bend. This one too can't bend at the tip. Life sucks. So this tube fitting looks like it could use a little bit of cleanup wherever I know I brought it in. It's on here somewhere. There it is. But that's probably not going to work. So what I'm going to do is I'm going to use the use the wherever the cutting piece. I just had it. I'm scatterbrained right now. Here it is. I think I need to drill that out a little bit because it's cutting the PTFE. It's always nice to have drill bits on hand that are the correct size. So that chewed up a little bit. So we're going to go just a little in. And we're going to grab my X-Acto knife here. And we're going to cut a straight piece off. Alright, nice and straight. So I'm going to put this down to the end, just like that. Just like that. And I'm going to cut a small piece off again. And I'm sitting on my flashlight. Let's watch that video a little bit longer.
So at this point you want to remove the fan shroud. In my case, I have a bullseye. So then I'm going to go ahead and my mount should come. Go to temperature, click on nozzle, and go to temperature, go into the menu of your 5, 6, and 7 at one time. So what we're going to do is go ahead and go into the menu of your printer here, go to control, go to temperature, click on nozzle, and click on nozzle, and bring the nozzle up to temperature. So that's going to be 4, 5, and 6, which would be clear the hot end, reset the nozzle, so there's nothing here. Prepare the hot end, and heat up the hot end.
So
PTFE fitting here. It'll heat it up right now to clear any plastic out of. So now remove it. Don't forget it's very hot at this point.
So I'm sitting on top of my
So now we move on to
stuff. So I need to open it.
To clear any plastic out of the throat by passing it from the top down through the heat block several times. That's like this. You just want to push. Pull it through. I just happen to have some extra, so if you have your stock one, you can use that as well. You're going to do that a couple, 3 times here. Just to make sure nothing's coming out and there's nothing clogged. So if we go on, we want to go to 11, which we want to make sure there's no plastic matting or surface on the back of the nozzle before we install. So we look at our nozzle here, and we look at the back. And if there's no plastic or filament melted on that, you're good to go. Step number 12. What we need to do is start screwing in the nozzle to get it tight. Now be careful, because this is going to be very hot. So get it started and set your temperature to about 20 degrees over the operating temp that you usually run at. Right now mine is set at 240 degrees at the nozzle. So then what I'm going to do is make sure it's just hand tight. We're going to take our pliers here. We're going to hold the block, and we're just going to make sure that the nozzle's tight. So hold your block like this. Just give the nozzle a quick tighten so the block doesn't turn. And everything should be great. That completes step number 12. Now we're on to step 13. The first thing we're going to do is we're going to cut just a little bit off the end here of the PTFE tube, just to make sure it's straight. So with Luke's guide, you want to use your X-Acto knife. Then we're going to go ahead and push the tube in, make sure it's all the way to the end, hold it in place, and cut right down in there. This should give you the exact cut that you need for your printer. In my case, we're using an Ender 3. Now that your PTFE tube is cut, you should have the PTFE tube and a washer that you printed that you checked earlier to make sure the filament would go through. We're going to continue step 13 and install all the parts. So we're going to go ahead and take and push our PTFE tube down into the bottom there, and you should see it way down in there. You'll see the blue. Then you're going to go ahead and take your washer and place it right in there as well. Then we're going to take some filament and just make sure everything passes through and it looks good. So now that we got the PTFE tubing down in there and the washer down in there, and our piece of filament cut to 100 millimeters for testing, that takes care of steps 16, 17, and 18. Keep in mind, in step 15, it does say you can use the stock tube by cutting just a little bit off that you need for this. In step 19, we're going to go ahead and hand screw the Bowden fitting into the top until it just touches the washer. So I'm going to go ahead and try to do that now so you guys can see. Just so it touches that washer, just like that. 20, we want to take the piece of filament that we talked about earlier and push it through the top, moving it up and down slowly, just to make sure that path is clear first. So make sure you get it in there. You can go up and down through the tube and that washer. Then what you want to do is take your wrench again and just, while you're moving it, tighten it just enough so that it won't back off easily when it's being used, okay? And you want to keep moving your filament up and down. This is very important to keep the alignment of everything tight. Now the first time that I did this fix, I got it too tight and I actually squashed that washer and it didn't allow the filament to go back in the end. So please make sure you're moving your filament down, keeping that path nice and clear, and then do not over tighten fitting here because you don't want that to happen. Step 21 talks about the small space between the shoulder of the fitting.
We're going to, now that this is heated up, I'm going to grab this.
That's going to be there because the washer is in there, and it ensures that the spacer is being compressed and compressing the PTFE lightly into the nozzle and inside of the hot end down here. So this is okay as long as your fitting is tight and it's not going to reverse itself back off. In step number 22, we are almost done. So we're going to take our PTFE tube current that we have, and we're going to go ahead and feed it into the top until it bottoms out and it's nice and tight in there. Make sure that you lift that collar once you get it in there and it isn't going anywhere. I prefer to put a small zip tie on there so I know that that collar won't come down. especially with the stock fittings. These collars seem to be weak and they seem to pop off. So I like to throw a zip tie on mine.
So whatever happened to my tube, the little tiny tube that I had, there it is.
So after step number 22, this is where I would like to put everything back together. So we're going to go ahead and put the mount for the bullseye back together, along with the fans and the bullseye duct itself.
And where
Go ahead
the,
and get everything screwed in tight.
there it
Whether you have
is.
a stock fan housing or an aftermarket one, just remember that when you're going to put this back together, the sticker of the fan, you can see there, goes face in towards the block there. So we're going to go ahead and get this screwed back together. So now, all I would do is take a zip tie and hold that back down like I had it before. And then we move on to the last step. For the last step, number 23, we're just going to go ahead and load the filament through. You'll get it through the PTFE tubing and you'll feel it go down through there. Once you get it far enough, you can start feeding it down through your nozzle and making sure it flows freely. Just like that. So there's one more step I need to address. I forgot to put my silicone sock back on. So we're going to go ahead and be careful because it's still hot.
Don't tell me I'm going to have to print another one, because I just lost it. I hate when things fall. There it is.
Good to go now. Congratulations, the fix is now done. You can enjoy better back pressure because you've eliminated that small void that was left there by the design of the original flow path. Don't forget to check out the maintenance and frequently asked questions on page 30.
You're out of Captain
this
Crunch, huh?
guide. Also, if you like the video, please subscribe and click the little bell if you want to be notified below when the next video comes out. Thank you so much. You guys have a great day.
So let me go grab my tools, whatever I did with the fat end of it.
Stepper motor driver upgrades part 2. TMC 2208 showing all 3 modes of operation.
I need to listen to that one too. So somewhere over here is a missing tool. There's a missing tool. Here it is. So. Well, that got too hot and melted. And I got it too hot and melted again. I am a smooth operator when it comes to this stuff. That should be enough. Okay. So now I'm going to get the, where's the tube? I lose things easily here because I'm half blind. Tube, tubular. Where are you, tube? I know you're around here somewhere. How do we miss a blue tube? Very simple. It's on the ground with all the black wires. And my blue crimps. Let's put this blue crimp back on. And let's put this little thing back in. So that should take care of that Bowden tool issue. So I can put this back together, but it is super hot. So I need to cool it down. So nozzle back to 0. Control, main, info screen. My back. My neck. My back. Wow.
This is the second video in a series of guides on how to upgrade your stepper motor drivers on your 3D printer. In the last video, we covered the basics, including the standard A4988, as well as upgrading to the TMC 2100. The TMC 2100 is the cheapest and the simplest of the silent stepper motor upgrades, but today we're going to step it up a notch by going to the 2208. But before we get started, here's a couple of reminders. You can't perform this upgrade if you're running a main board with integrated stepper motor drivers like the Ender 3. Instead, you need a ramps or ramps compatible board where there's a slot to plug in a separate stepper motor driver and you can change them at will. This guide is based on the MKS Gen L, and I previously made a guide on how to fit this to an Ender 3. A reminder too that the main chip is a TMC 2208 by Trinamic, but there's a lot of variation in the breakout boards by different companies. I'll try to cover things in general terms, but you might find slight variations when you do this yourself at home. Now that we're ready to go, let's have a look at this 2208 in more detail. The 2208 is a step up from the 2100 that we covered in the last video. It offers 1 to 16 microstepping with interpolation to 256 steps, or even native 256 microstepping over UI. To upgrade the main board. It's quiet and it has two modes, Stealth Chop 2, which has improvements in torque over Stealth Chop 1, and Spread Cycle. It is more expensive than a 2100 and it may skip steps in Stealth Chop mode, and it definitely will run hot. As the datasheet says, there are 3 modes of operation that we can select from. Mode 1 is Legacy mode, and it's a drop-in replacement for the A4988. It has 1/16 microstepping with 1 to 256 interpolation, Stealth Chop 2 for quiet operation, and we set our stepper current or VREF manually via a trim pot. Mode 2 is pre-configuration via OTP. It's the same as Legacy mode, but we can optionally permanently change from Stealth Chop 2 to Spread Cycle. This is achieved via some jumper wires, PC software, and one-time programming. Mode 3 is Dynamic UART, and it lets us have it all. We wire it to the main board, and that means with the software we can set the VREF, we can dynamically change between Spread Cycle and Stealth Chop, and we can have native microstepping up to 256 and G-code diagnostics. We're going to start with Mode 1, which is a drop-in replacement but still much quieter than A4988s. We're going to look at setting microstepping, firmware, as well as adjusting the VREF. Firstly, thank you to the Crab for leaving a really helpful comment on the jumper pads on the underside of the board. For your 2208 to operate in Legacy mode, you need to check the underside and make sure that these little jumper pads are not connected with solder. Some have 2 pads, some have 3, but either way, they should be separate. We can see that we need the first 2 jumpers left in to activate 1 to 16 microstepping, and it doesn't use a third config pin, therefore we can remove the third one furthest away from the capacitor for each stepper motor driver slot that you're intending to install 2208s. Like the TMC 2100, the 2208 has its chip on the bottom, not the top. You should always check for the ground and direction pins and match those up to the main board before you plug it in. Don't rely on anything else. In a previous video, we established that our max current is 0.84 for X, Y, and Z, and 1 amp for the extruder. The 2208, however, uses root mean squared, which is more of an average or typical rather than a max. Fortunately, we just need to divide it by 1.41 to get our RMS. Calculating the VREF is the RMS current times 2.5 divided by 1.77. When we crunch the numbers on an Ender 3, that gives us values of 0.842 and 1 volt. However, it's always safer to use 90% of this, giving us 0.76 and 0.9 volts. When adjusting our VREF, we need to be powered from the 12 or 24 volt main connection rather than the USB. We're going to set our multimeter to a maximum of 2 volts. We're going to place our black probe on the ground for the main power supply and our red probe or positive inside the little trim pot, but it will also work if you use the triangle via next to the enable pin. The value you see on the multimeter screen is your current VREF. To adjust it, the easiest thing to do is to take an alligator clip, clip one end onto the red probe of your multimeter, the other end onto a small flathead metal screwdriver, and then you will get a live reading as you put it into the trim pot and adjust. Only very small movements are needed to change the VREF dramatically, so take your time, and it's safe to unplug the stepper motor so you don't damage it during this process. These drivers get hot, and there's a thermal pad on top where you install your heatsink. These really big ones here are only suitable for mode 1. If you're going to do the modes later in this video, please install a smaller one. If changing from A4988s, there's only one thing that needs adjusting in the firmware. In configuration H, search for invert_X, and then toggle between true and false for any axis that you're installing one of these stepper motor drivers. After this, you're ready to upload your firmware to the board. We're up and running with Stealth Chop 2, so let's test the noise by doing a homing test, and I like this because it's repeatable, there's no interference from things like the part cooling fan. It seems to me like that's just as quiet as the TMC 2100s. Next, while I was doing my test prints, I decided to verify my VREF by making sure that the stepper motors weren't getting too hot. And again, everything was good. It's really strange, but with the stepper motors being this quiet, the part cooling fan all of a sudden seems so loud. But anyway, let's have a look at the test prints. My custom designed test print for 100mm per second again showed no signs of missteps, so that's another win for Stealth Chop. The Benchy suffers from the same problem from the worn lead screw, so please ignore that and focus on the rest, which is good. No zebra skin artifacts and no other issues with skip steps. Another tick for Stealth Chop mode. On to mode 2, and let me tell you, this one is not for me, and that's because OTP pre-configured stands for one-time programming, and that means permanent. On the TMC 2100, if we want to change to spread cycle from Stealth Chop, we can simply solder a wire across the configuration pin and it's in that mode. If we want to reverse it, we simply unsolder that wire. With OTP and these 2208s, it will be irreversible, meaning you can't change back to Stealth Chop no matter how much you want to. With that in mind, I'll just do a brief overview so you can see exactly what's involved. To be able to do OTP, you need to solder those little pads together as shown. Whether you have 2 or 3, they all need to be connected. This is a pretty tricky job. Linked in the description is a page to the configurator. There's a link up the top of that page, and that will take you to a download page for the software that you require. Next, you'll go back and download the file from the second link. Once you open that file, you see that there's parameter for the TMC 2208, but we're not ready to go yet. Back on the instruction page, you'll see that there's a schematic for a standalone connection, which is what we need. You'll also need a USB FTDI breakout, which I just happen to have lying around, and here's my attempt at wiring it up with jumper cables. You can now connect, access the settings, but remember, anything from the OTP tab will be permanent. If you still really want to do this, in the description there's a link to a very detailed video guide from Keith Young. Not for me, but if you really want to go that way, Keith's video is linked in the description. On to mode 3. It's more complicated to set up, but definitely more powerful. Now to work this out, I spent a lot of time looking at data sheets, but at the end I found this awesome instructable from Sean Sadler. It's for ramps instead of the MKS Gem L, but it was still excellent in verifying what I had done was correct, and it's linked in the description below. Let's break this up a little bit and we'll start with our physical wiring and soldering. Just like with mode 2, it's time to solder close the jumper pads underneath to connect them together. This is very tricky. It was the worst part of this job. I'm trying to account for breakout board variation here, but some boards only have 2 pads and some boards have 3. Either way, you solder to bridge them all together. Until we do this, the pins that we need to connect to the main board to communicate won't actually be connected to the main driver chip on the breakout board. On a 2-pad board, it will be the pin labelled PDN or UART. On a 3-pad board, it's the middle 2 pins on the DIR side. These pins need to have their direction reversed, and that means this fat heatsink is in the way. Therefore, I had to pull mine off to replace with a smaller one later on. The modification we're making is shown on the driver on the left, and we're going to start by getting an X-Acto knife and cutting away either the 1 or 2 pins we've previously identified. We now need to desolder the pins, and I used a solder sucker to achieve this. After I did this, pretty much all of the solder was missing from the holes on the breakout board. This meant I could take my soldering iron and apply some light pressure while it heated up to push the pins through, and then I could get a set of pliers to pull them out from underneath. I switched the direction of these pins to face upwards, and then I soldered them back onto the breakout board. After this, I swapped the heat sinks from my 2100s to the fat ones that came with these. To make our communication cables, we need 8 DuPont wires and 4 1K resistors. You're going to cut one of the jumper cables in half, put on some heat shrink, twist the ends, and then solder the 1K resistor in place. After this, I slid down my clear heat shrink tubing, heated it up, and isolated everything. I did the 2 black ones as well, just to keep everything together and tidy. When I was making my 4 sets, I made sure the resistor was on the same color each time, in my case the orange wire. If you're working with a double pad breakout board and there's only 1 pin sticking up on your driver, it's pretty much the same, except after the resistor, the 2 wires join into one, so there's 2 on one end and 1 on the other. Here is a pinout diagram for the MKS Gen L, and we're going to plug all of our new cables into auxiliary 2. Here is how the wiring goes with the standard Marlin pin assignments. We skip the left-hand ground and 5-volt pins, and then they go in pairs. Please note that the black box shows you which one the resistor wire should be plugged into. Now let's do this for real on our main board, and you can see auxiliary 2 clearly marked. Remember that I have my 1K resistor on the orange wire each time, and when you plug them into the stepper motor driver, it doesn't matter which one goes in which. Now we plug them into the labeled position one at a time, X, Y, Z, and finally the extruder. Remember, for my cables I have the resistor on the orange wire, so it's the right hand of the 2 pins for X, and the left hand pin for Y, Z, and the extruder. If you get this wrong, nothing will blow up, but it won't function as it should. This diagram is linked in the description below. Onto the firmware, and fortunately in Marlin 119, which we're using here, everything is well set up and well documented. On the Marlin firmware page, if we come to documentation, hardware, and then Trinamic drivers, we'll receive this page here, and it has a summary of what is supported by the Marlin firmware. As we can see, for the 2208, we can control it via UART, and it tells us a summary of the features that we can expect. The first thing that we have to do, as it says here, is to install the library. With our firmware open, to do that we come to Sketch, Include Library, and then Manage Libraries. After this we can type in 2208. This should be only a single library. You can see that I've already installed it, but if you haven't, click on Install and you're good to go. If we scroll down to Features and Configuration Options, we'll get a summary of all the things that are to come in the firmware. So if there's something in this video that you don't understand, please follow the link and read up on it further. If we scroll a little bit further, there's also a list of supported G-code commands you can type in through terminal to interface with your 2208 drivers. Just be careful, because not all of these listed here are compatible with the 2208, and not all of them listed here are compatible with every version of Marlin. We're working with Marlin 119.
I just realized that I think I swept my screw.
We can see that it's only compatible with Marlin 2.0. We can also see that if we go to sensorless homing, that this feature is only compatible with TMC 2130. There's lots of other great information on this page, including a list of links to help you out and to give you more information. Just a reminder that you need to invert the direction of your stepper drivers if you haven't already, and we do that by doing Control F, typing in X_0.
I've got some small
that will take
ones.
us to the section where we can invert the stepper direction. You can see I've already changed mine from what comes stock on the Ender 3. Next thing we're going to search for is 2208.
I just swear I put it over here though.
Installed, you're going to type in TMC 2208 as it says in the examples. Be careful to note that it goes X, Y, Z, and then extruder 1 all the way down here. Also, don't forget to uncomment each of these. That's everything in this part of the firmware, so now we can switch to configuration_adv.h. Once again, we're going to search for 2208. That'll take us to the section TMC_smart, where we configure everything for this stepper motor driver. There's some information here about how to wire them up, but we've already got that done, and also that we need the library, which we've also already installed. We already know that we can interpolate up to 1 to 256 microsteps, and setting this to true will achieve that. Our VREF is also now set in the software, and we know our values for the end of 3 are 760. And if we scroll down to the extruder, 900.
It's gotta be in here
Because we're
somewhere.
operating over UART, we can actually set the native microstepping all the way up to 256. If you do so, however, you'll need to change your steps per millimeter elsewhere in the firmware. That's because by default it's set for 1/16 microstepping, which means if you request 800 steps, that axis will move 10 millimeters. Requesting 80 steps with the higher microstepping will only move at 0.625 millimeters. The microsteps are 16 times higher, and therefore the steps per millimeter must be 16 times higher as well, with 1280. Because of this, I'm going to leave mine on 1 to the 16 with interpolation all the way up to 256. Now you notice some sections are only for the 2130 and they're labeled as such, so please keep scrolling past those. Now we get to the section where we can turn on and off Stealth Chop. You can see that by default it will be enabled, but if you want it to run in spread cycle, it's as simple as commenting this out. I'm going to leave mine enabled at this stage, but it's really nice to not have to make this change permanently like you have to with the OTP programming. If you're intending to get some diagnostics from your stepper motor driver, you should uncomment define motor driver status. There's a list of G-code we can use with this just above. Now hybrid threshold is something really exciting. We can get it to dynamically switch between Stealth Chop 2 and spread cycle depending on the speed of the movement. If we uncomment this and then input the speed in millimeters per second for each axis, the printer will run in Stealth Chop until it reaches this speed, and then it will change over to spread cycle. The last thing I'm going to do is uncomment define TMC debug so I can access all of the data possible over the UART connection. After this, we're ready to save and upload to the printer. So our firmware has been flashed after being updated, and we know that the firmware should be able to talk to the stepper motor drivers, but how can we verify that it's working? Well, to do this, we need a piece of software with the console to send G-code directly. You can use Simplified 3D, Octoprint, or in my case, I'm going to use Prontoface. The firmware has successfully uploaded. I'm switching to Prontoface so I can have a free programs user terminal. I'm going to connect. And now I'm going to type in the diagnostic tool, which is M122. Now it spits out a bunch of information about our stepper drivers, but if you want to make sure that they're actually connected, you need to check these lines down here. If any of these reads all zeros or all Fs, that means you have something wrong with your wiring. You can see here that my Z is reading 0000, so I'll need to check my connection. Beyond that, some of the other things that are handy are the set current. You can verify that. You can verify your microstepping is set correctly, and you can look for these pre-warnings about the stepper motor driver running too hot. This would be a nice thing to poll partway through the print, and how the stepper drivers were going. Now I fixed that problem I was having by simply unplugging and plugging the wire back in. And you should know that if something does become unplugged, it degrades back to legacy mode. Keep in mind that if you've set up your steps per millimeter for 256 native microstepping, if it becomes unplugged, it's going to switch back to only 16 times microstepping. And that means that any movement is going to go 16 times further and probably collide, so beware. Since this is now as easy as commenting a single line in the firmware, I took the chance to turn off Stealth Chop and compare how it prints with spread cycle, starting with a noise test by homing. In terms of noise, I'd say it's about halfway between A4988 and these same drivers in Stealth Chop mode. While it's printing, the part cooling fan is still the loudest thing, but you can definitely hear the stepper motors now. One thing to note is the annoying whine that is audible while the steppers aren't moving but are energized. Next up, I started the test prints, and again I tested the stepper motor temperature. They're a little bit higher than before, but it was simply a slightly warmer day. Well below the too hot to touch threshold, so let's have a look at the print quality. You'd have to say it's absolutely identical, and that makes sense too. Unless there was a problem like steps being skipped, there's nothing to fix, and therefore these stepper motors aren't going to show anything different. We know there's no print artifacts with these stepper motor drivers. What we're seeing in both cases is exactly what the slicer had prepared in the terms of the G-code. So we've reached the end of this video, but the question begs, why would you choose the 2208s over the cheaper 2100s? Well, there's several reasons. Firstly, it has Stealth Drop 2, so there's slightly more torque for the same amount of volume. This should mean more reliability when printing at higher speeds. The real beauty comes when you operate it with the UART mode, and that means some intelligent features. It's pretty nice to be able to set the VREF without having to turn the printer upside down and twist anything with screwdrivers. But the best feature is probably the hybrid threshold. If you don't want to have to choose between having a quiet, refined printer and one that has a lot of torque, you don't have to with this setup. You can have a printing profile with slower speeds that are below the hybrid threshold you set in the firmware, and it will remain quiet. But if you really want to knock something out and make sure it's reliable, simply set the hybrid threshold below that higher speed and it will switch over to spread cycle and you should be safe. Now, one final note. I've seen a few guides saying that you should use a 2208 for the extruder, and instead you should use an LV8729. Well, I've never seen a justification given for this, and based on my tests, I can't see any reason why you would need to do that. In the next video, we're going to step it up again, and I'm going to provide a full guide to TMC 2130s. That's going to step things up again in terms of smart features. Thank you so much for watching. Please leave your thoughts and comments below, and until next time, happy 3D printing.
G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe and make...
So, yeah.
affordable and capable MKS Gen L.
Let's get some of these things out of the way, because now we are going to go and...
The Creality version of the Melzi mainboard found in the Ender 3 and some CR10s definitely doesn't have a good reputation. You have to remember on the Ender 3, however, that it's a budget 3D printer, so it makes sense to include a budget mainboard. The main problem, in my opinion, is that it doesn't come with a bootloader, which is going to put a big barrier in place to someone new to 3D printing, upgrading their firmware. It also has a really small microcontroller, approximately half the size of what you'd expect to find in a lot of other offerings. Now, I've managed to get a BL Touch and filament runout sensor running on this board, but every time I've added something new, I've had to trim off something old. Surely there has to be a better way. And there is. This is the MKS Gen L. It's another budget 3D printer main board, but it's only going to set you back a little bit over US $20. Let's start this video by having a brief comparison and outlining exactly why you would upgrade to this board. Here are the two boards side by side, the old on the right and the new on the left. We can see the new one is quite a bit bigger, but let's get into some detail. If you've done any Ender 3 modding, you'll know it's quite hard to get everything to fit on the microcontroller, but the new board comes with a Mega 2560, and yes, that comes with a bootloader, so we don't need to worry about that step either. The MKS has 5 instead of 4 stepper motor driver outputs, and you can pick whichever ones you want. There's min and max end stop inputs instead of just min. There's an extra thermistor input, and there's an extra 4 auxiliary or expansion ports. Unfortunately, it doesn't have an onboard SD card slot, but it does make up for that by having 4 servo outputs compared to 0 dedicated for the Melzy. But what does all this mean? Well, we can have more features on our Marlin firmware because it easily fits on the 2560. We can easily add extras such as BL Touch, filament runout detection, and advanced firmware features such as S-Curve and Linear Advance. This board has support for dual extrusion with the extra stepper motor driver as well as the extra thermistor input. We have compatible touchscreens which you can buy off the shelf. You can upgrade your stepper motor drivers to the silent dynamic ones. In general, because we have more input output, we can have extra features such as quieter fans. After this upgrade, you'll be cutting down on noise because the hot end cooling fan won't come on until you're above 50 degrees. The only downside is it doesn't have an SD card on board, so unless you upgrade the LCD, you're going to lose that functionality. There is a bit of a hassle in installation, but with this guide I've tried to make it as straightforward as possible. Our first step is to print this replacement mainboard enclosure, but this video wasn't always going to feature this. Let me explain. I started this upgrade process only planning to make a little adapter that went inside the factory metal casing. After measuring the old and new mainboards, I put together my design for the adapter, and I ended up going through a few iterations before I was completely happy with it. This version was designed to slip over the mounting bosses inside the metal cavity, and then you use the existing screws to hold it in place. I actually finished shooting the whole video with this version of the mod, but then I decided it wasn't quite up to scratch. Partly because you had to bend the metal frame to have access to the USB slot, and the other main issue is that it was only suitable for an Ender 3 Pro instead of the normal Ender 3. It looked pretty neat, but I decided it was back to the drawing board. After a very late night, I developed this 2-piece printable design. This part replaces the main board sheet metal housing on the Ender 3 or the Ender 3 Pro. The fan knob blows over the stepper motor drivers, and it's got a hinging door on the underside that clips in place for easy access for adjustments. There's a Thingiverse link in the description, and both parts print easily without the need for any support. It's a good test of your first layer to see how smooth you can get it. Now that we've got our printed parts ready to go, it's time to disassemble the old setup and prepare our new mainboard. You're going to start by removing all of the little bits of hot glue that stop the factory plugs from coming undone. After that, you're going to unplug everything one at a time and label them as you go with masking tape or something else so you know what's what when it comes time to put everything back together. Of course, a fair few of the components are already labeled X, Y, Z and E, so you won't need to worry about doing those. I've made up this handy diagram and I put the link in the description. You should use it if you're unsure what the components are, and you can use these to label everything. A lot of the plugs look exactly the same, so trust me, you're really going to want to do this. It's going to help you out a great deal later on. After everything's labelled and unplugged, it's time to remove the 4 short M3 screws that hold on the Melzy board. Now is the time to install your stepper motor drivers. You need to look at the labels underneath and match that up to the labels on top of the MKS board. I had the same A4988 stepper motor drivers lying around that came from the original board, but they were off another machine. I thought it was worth taking the time to measure the VREFs on the factory board and then set very similar values on the new stepper drivers going into the MKS board. Please remember that wiring checklist is in the description, and you can print it out and use it when you're disassembling and labeling all of your plugs. Now that we've got that out of the way, it's time to reinstall the new mainboard. The cutout for the wiring and the underside of the printer has some pretty sharp edges, so I found this foam tape and I applied it to all of those sharp edges. First thing we're going to do is slide our printed part into place.
Wow.
It attaches the exact same way as a factory part, which means 2 large bolts on the front of it and then 1 small bolt from the top going through to the extrusion reaching underneath the printer. We now mount the MKS board on the tabs provided using the factory short M3 screws. There's a slot provided in this printed housing for the USB cable to go inside for firmware updates or for printing from Octoprint. Now comes the straightforward job of plugging everything back in, and I started with the main power supply wires. You have to be careful with these fittings that you have it open before you put it in, otherwise you can get caught in the underside of the fitting instead of the opening where it's actually meant to go. From this point, almost everything is plug and play. So I inserted the bed heater wires, the hot end heater wires, the hot end cooling fan, the part cooling fan, the 4 stepper motor plugs, the bed thermistor and the hot end thermistor. The only plugs you need to modify in the whole thing is for the end stops. There's 2 locking prongs.
Okay, shit. I have a little issue here. One of the screws on here is so freaking tight for some reason. Damn factory. So, I'm trying to figure out how the hell I'm going to get it off. Because I can't. Let's see. That won't fit in it. Something fell over. But it wasn't this. So that's not going to fit in there either. Shit me. Why is that so damn tight? That should do it. Come on. There we go. So, this screw, I'm just gonna put over here. So some of the things that I need to take off here is the stepper motor driver. So we're gonna take everything off here. First we're gonna label stuff. So I'm going to cut these off. These things don't no longer want to work anymore. Cheap. But then again, I tried turning a screw with it. So I'm not surprised they're not working very well. So what we're going to do here is we're going to label stuff. The USB literally ripped right off the board. just literally ripped right off the board. Let's see. See right there. Popped right off. So what we're going to do here is we're going to do, let's take out these stepper wires, smoothers. And we're going to take one or two of them, so take two of them and put them into the other machine a little bit later. Okay, so this is power. So I need to find some masking tape. So somewhere in here is a pen. Where's the pen? The pen is missing. Pen art is missing. Peanut. Pen is missing. Pen is missing. Somewhere. Ah, there it is. Got one. So, where's my butt pillow? I thought I brought my butt pillow in. Oh well. First things first. Let's.
And heater wires, the hot end cooling fan, the part cooling fan, there's shelf. I actually finished shooting the whole video with this version of the mod, but then I decided it wasn't quite up to scratch. Partly because you had to bend the metal frame to have access to the USB slot, and the other main issue is that it was only suitable for an Ender 3 Pro instead of the normal Ender 3. It looked pretty neat, but I decided it was back on the side that clips in place for easy access for adjustments. There's a thing of parts ready to go that stops the factory plugs from coming undone. After that, you're going to unplug everything one at a time and label them as you go with masking tape or something else so you know what's what when it comes time to put everything back together. Of course, a fair few of the components are already labeled X, Y, Z and E, so you won't need to worry about doing those. I've made up this handy diagram and I put the link in the description. You should use it if you're unsure.
H. So H is hot end fanned. So and the little screwdriver is missing. So we're going to take these two off. So hot end fan. Let's see, B is heater bed. B is heater bed. Oh, that's over there. And the very last one is C. So this one would be hot end. Hot end out. These two. So there's the USB. Dangling. Just dangling. So now we have the daunting task of scraping off some of these stepper things, which I'm not looking forward to because I'd like to reuse them in the other machine, since that machine's probably not going to get an MK upgrade. So let's see what I can do here. That's one. That's two. This one's gonna need a re-paste. Yuck. Goo. Now, got a little problem with this one here. It's so close to end. Alright, 4 stepper drivers out of the machine, and I can go and grab the bracket from the other one. So let's see the new board. They really stuck that in there. So let's figure this out. Here. I could put it on this way. But all the wires would be
Sure what the components are, and you can use these to label everything. A lot of the plugs look exactly the same, so trust me, you're really going to want to do this. It's going to help you out a great deal later on. After everything's labeled and unplugged, it's time to remove the 4 short M3 screws that hold on the melting board. Now is the time to install your stepper motor drivers. You need to look at the labels underneath and match that up to the labels on top of the MKS board. I had the same A4988 stepper motor drivers lying around that came from the original board, but they were off another machine. I thought it was worth taking the time to measure the VREFs on the factory board and then set very similar values on the new stepper drivers going into the MKS board. Please remember that wiring checklist is in the description and you can print it out and use it when you're disassembling and labeling all of your plugs. Now that we've got that out of the way, it's time to reinstall the new main board. The cutout for the wiring and the underside of the printer has some pretty sharp edges, so I found this foam tape and I applied it to all of those sharp edges. First thing we're going to do is slide our printed part into place. It attaches the exact same way as a factory part, which means
Hi guys! So, this board is equipped with Allegro A4982 non-replaceable drivers, so I had to buy the MKS Gen L board as well. The board I got already includes 5 TMC 2208 drivers. You can check the link in the video description. These drivers are a great choice for the X, Y, and Z axis.
so I need to figure out.
I will use the LV8729 because they perform better on the extruder. These drivers have a great performance and they can make the stepper motors run silent. I like to run them all at 1/16 steps. And to make them work this way, you need to configure the jumpers on the board.
So all of these are
3 jumpers. Mode select 1, 2, and 3, or MS 1, 2, and 3. For the TMCs, you need to keep all except jumper MS3. For the LV, you need to remove all except jumper MS3. Now, before installing the drivers, you need to install the heat sinks. Place them on the top side and above the Before installing the drivers, you need to install the heat sinks. Place them on the top 3.
Damn it.
Now, before installing the
So I need to remove those 3.
the drivers, you need to install the heat sinks. Place them on the top side and above the chip. Make sure they don't touch any of the side pins. On the back side you can see the header pins. On one side they are blue and on the other they are black. This will tell you the orientation of the drivers. The blue header pins must match the green.
So 1, 2, 3, so I'm using 3. So we're installing 3 of these. So 3 of these. And 1 of the LVs.
Ones of the board and the black with the black ones of the board. This Gen L board is not an exact fit of the MKS baseboard, so I bought these standoffs because I will need them later, as you will see in the
Oops. Uh-oh. That one was a little skinnier. So we are going to place this here. These screws and put it back inside. Ants. More of these small screws. More screws.
Few minutes. Next, you need to adjust the output current for the motors. This is done by turning the little potentiometer on each driver. To do this, you will need a voltmeter or a multimeter and an alligator clip lead. You will also need to connect the board to the power supply. You can use the printer's power supply, but if you do, just connect the power wires for now. Do not connect the motors. I have a spare power supply, so I will use this one as it's easier to show you. Do not use the 5-volt USB connection to adjust the drivers. You need 12 or 24 volts to do this step. These drivers run very hot, and the more output current they provide, the hotter they get. So you need to think carefully how much current you will choose to use. For the stepper motors of the Tivo Tornado, I will be using 0.85 amps for the X and Z and 0.9 for the Y and the extruder. The formula for the TMC22
It is more expensive than a 2100 and it may skip steps in stealth chop mode, and it definitely will run hot. As the datasheet says, there are 3 modes of operation that we can select from. Mode 1, definitely change ref. With an A8 to operate in legacy mode, you need to check the underside and make sure that these little jumper pads are not connected with solder. Some have 2 pads, some have 3, but either way, they should be separate. We can see that we need the first 2 jumpers left in to activate 1 to 16 microstepping, and it doesn't use a third config pin, therefore we can remove the third one furthest away from the capacitor for each stepper motor driver slot that you're intending to install 2208s. Like the TMC 2100, the 2208 has its chip on the bottom, not the top. You should always check for the ground and direction pins and match those up to the main board before you plug it in. Don't rely on anything else. In a previous video, we established that our max current is 0.84 for X, Y, and Z and 1 amp for the extruder. The 2208, however, uses root mean squared, which is more of an average or typical rather than a max. Fortunately, we just need to divide it by 1.41 to get our RMS. Calculating the VREF is the RMS current times 2.5 divided by 1.77. When we crunch the numbers on an end of 3, that gives us values of 0.842 and 1 volt. However, it's always safer to use 90% of this, giving us 0.76 and 0.9 volts. When adjusting our VREF, we need to be powered from the 12 or 24 volt main connection rather than the USB. We're going to set our multimeter to a maximum of 2 volts. We're going to place our black probe on the ground for the main power supply and our red probe or positive inside the little trim pot, but it will also work if you use the triangle via next to the enable pin. The value you see on the multimeter screen is your current VREF. To adjust it, the easiest thing to do is to take an alligator clip, clip one end onto the red probe of your multimeter, the other end onto a small flathead metal screwdriver, and then you will get a live reading as you put it into the trim pot and adjust. Only very small movements are needed to change the VREF dramatically, so take your time, and it's safe to unplug the stepper motor so you don't damage it during this process. These drivers small movements.
So 7, 6, and 9.
The enable pin. Probe on the ground for the main power to a maximum of 2 volts. We're going to place our black probe on the ground.
So I've got an issue here. I lost my screwdriver again. So our negative lead is definitely on this side. So we're going to plug that in. And we're going to plug this side in to the bread. Not going to come out. So I want to check something, how close these are going to be. So that's not going to be too bad. It's not going to be too bad, because I can run the USB over there, but I'm a little worried about how far this has to go. Can it reach? No. There's my problem right there. Got a little bit of a problem with where the EXP1 and EXP2 will go. gonna have to print out a new cover. So let me go find where that cover went. I believe it's under my collections. Likes. So let's go enter 5 smart controller. I thought I saw an ender 5 wrap. Let me check my. I know I have a whole bunch of models. Let's see. Printer mods. Let's see. Okay, that's for the adapter. Let's go ender 5 wrap. Smart controller. This is definitely not the smart controller I was looking for. Different one. looks interesting, but let's link that in a new tab. Let's check this one out. But it needs mounting. Okay, that should work. Or at least I think it should. Right? So, let's go over here. Files. printer mods, and we're going to need the RepWrap Smart Controller LCD case mount. So we're going to extract that. So let's open up Cura. So how do I build this? Print as is with supports. So I need my, where's my, yes.